Math 76, lesson 99, volume of a rectangular prism. Okay, there's two ways to do this. The book way, you can find at the bottom of page 472. It's right there. It's volume equals length times width times height, right? And here they show you the length, the width, and the height. Whoa, calm down, camera. All right. So here we see the length, the width, and the height, right? So it's measuring one length on every single dimension or axis. Now, let's look at an actual rectangular solid. So I've got a rectangular solid right here. If we were to use that formula, I would take the length, which would be the height of the object. So if I look at it flat at this dimension, the length or this distance is the same everywhere that I go. So if I travel in this direction, I'll go the exact same distance along the top of the shape. It doesn't matter if I rotate it either. I'll get the same length, right? So that's how we spot those. They're all the same, right? So that's going to be one number. Now let's talk about the width. The width would be if I were to turn it this way, right? So that's the length, that's the width. There we go. I've got two distances. Even if I rotate it this way, it's still the same distance on the back, same distance right there. Okay. Now the last one, the height, right there. Kapow. There's the height, right? That distance. Okay. And it's the same distance here, same distance here, same distance here. Okay? That's how that formula works. I'm not a big fan of that formula. I'm a big fan of teaching a more logical approach to this. You know, and it's kind of funny because with some math, I'm perfectly fine with algorithms and memorizing how to get the right answer. When it comes to things like dimensions and volume, I want to make sure you guys logically understand what's going on here. So if we look at these drawings on page 473, they give us a really accurate depiction of what volume is. And volume is a three-dimensional measurement of how much space an object can be occupies, right? So the way we measure that is it's imagining like the stories on a building. Volume would be like if we were to find the area of the first floor of a building and then multiply it by how many stories it has, right? Or in this case, we see with this cube, or not this cube, this rectangular solid, the sugar cube. So we have a base or a rectangular base that has a length of 5 and a width of 3, right? So if I can find the area of that shape, that's going to be 15, and I can even count it here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 square inches right here on the base. Now if I look down at the full shape, I've got that same base repeated 1, 2, 3, 4 times with a height of 4 inches. So the way we find volume is we take the area of the base and we multiply it by the height. And that's the formula that I want you to memorize because it's more logical and it works for more shapes than just the rectangular solid. And the way that I'm going to write this and annotate this is I'm going to put A of base, that means area of base, times height. And that is volume, right? Now, one question that kids usually have is which side is the base? Well, when it comes to a rectangular solid, the base is whatever side has a twin on the opposite end, or whatever, it's like the floor that has a roof, okay? A base cannot be a base unless there's an identical side directly opposite of it. So like, for example, if I were to choose this as my base, there would have to be another side identical to it, and there is, right? But the funny thing with rectangular solids is usually I have more options. Like this could be my base because I've got an identical piece on the other side. Now we get other rectangular solids like this. This is actually a rectangular prism. Now I'm limited because if I were to pick this as the base, there should be an identical side on the opposite end. But if I look, the opposite end there's no identical side. It's not there. Same thing with this. If I look at the opposite end for the identical side, I have no side. So with a shape like this, the base actually is the triangle, right? This is the base. There's only one option for the shape because this is the only shape that has an identical twin on the opposite end. And that's how we find what shape is the base. It has to have an identical shape on the opposite end. Right now, your rectangular prism problems, any side could be used as the base. So let's go ahead and solve. Let's solve this one. So let's say, we'll use a little bit of pretend. Let's say that this side is 2 centimeters, right? So I'm gonna sketch this as best I can. Whoops. There we go. I have just sketched this. Okay, so let's say that this side is 2 centimeters, this side is about 5 centimeters, and this side, let's say 12 centimeters. Okay. All right. Now, to find the volume of this object, I'm going to pick a base. I'm going to say that is my base right there. So I need to find the area of that rectangle. It's got a length of 5 and a length and a width of 2. So the area of that base is 10 centimeters squared. Now I take the area of that base, which is that part right there, and I'm going to multiply it by the height, which is 12 centimeters. So then I just have to take 12 centimeters times 10 centimeters squared. That gives me 120 centimeters cubed, all right, or cubic centimeters. Now this is the very last part of volume problems. Volume problems will always have a 3. The units will always be cubed, or they'll be called cubic units. So I can write 120 centimeters cubed, or I can write 120 cubic centimeters, right? Those are the 2 ways to write the answer. And the reason why is because volume is a 3-dimensional measurement, right? Area is a 2-dimensional measurement, which is why it says square units, and volume is 3-dimensional, which is why it gets cubed or uses cubic units. All right, well, that's all I've got for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.